Welcome to the deep dive.
Imagine looking into the night sky and knowing that beneath the surface of some distant planet, hidden oceans are just silently waiting. Oceans that AI, not humans, actually found for the very first time. Now, this isn't just, some cool sci-fi idea.
No, not anymore.
This is really a glimpse into the future of space discovery, and it's happening right now. Welcome to the deep dive.
Great to be here.
Today, we're jumping into some really groundbreaking news. Advanced AI systems, actual machine learning, helping astronomers detect really compelling signs of hidden oceans on distant exoplanets.
Yeah.
And what's truly remarkable, I think, is that some of these potential ocean worlds orbit red dwarf stars we often think of as hostile.
Right. Quite hostile.
Yet they still show these telltale signs of liquid water potential.
It really does change the game, doesn't it? This discovery, it could fundamentally transform how we understand where life might exist out there.
Absolutely.
Because if these subsurface oceans are confirmed, the probability of microbial life being there just skyrockets.
Like Europa or Enceladus.
Exactly like Europa or Enceladus right here in our solar system. It draws that direct, exciting parallel. So it raises this huge question for us.
Yeah.
Are we actually closer to finding alien life than we've ever been before? And maybe even more intriguing, how far can AI really go? Where else can it guide us in this hunt for new worlds?
That's the core of it, absolutely. So, okay, let's dive straight into how. How is AI doing something so, revolutionary here? For decades, we've had traditional methods, big telescopes, spectrometers.
And the tried and true methods.
Right. What exactly is AI picking up that those might miss? Why is this such a breakthrough?
Well, the real breakthrough is in AI's ability to detect incredibly subtle changes, tiny variations in starlight and gravity, even in a planet's orbital motion.
Subtle how?
These aren't just faint signals. They're patterns that are so nuanced, so deeply interwoven in all the noise and data that, frankly, our human-designed filters or even our most complex traditional models, they just couldn't reliably pull them out. It's not just that AI processes more data faster, though it certainly does that.
Right.
It's that it seems to be revealing entirely new classes of phenomena, patterns so intricate they just don't register neatly on our, conventional ways of looking. This isn't just automation. It's like an expansion of our scientific senses, our perception itself.
That's fascinating. So AI is seeing patterns we've basically been blind to. But Can you walk us through the specifics, the how? What data did it actually use, and what was the smoking gun that pointed to oceans specifically, not just, say, a very dense core or some other weird planetary thing?
Sure. So the AI crunched thousands upon thousands of data points. It pulled primarily from really successful missions like NASA's TESS satellite and ESA's Gaia Space Observatory.
Okay, TESS and Gaia data.
Exactly.
Yeah.
And its main focus was analyzing the mass and the density of these exoplanets.
Mass and density, got it.
And what it found was that several candidates, particularly these super-Earths, planets bigger than Earth but smaller than Neptune or Jupiter, they showed these distinct anomalies in their mass-to-radius ratio, a mismatch, essentially.
A mismatch.
Yeah, this specific signature, this deviation from what we'd expect if it were just a purely rocky or a purely gaseous planet of that size, it's best explained by the presence of a significant amount of subsurface liquid water.
No.
It's kind of like feeling a bowling ball and then feeling a beach ball of the exact same size.
Right, you instantly know.
That density difference tells you something profound about what's inside immediately.
Okay, that makes sense. So with AI pinpointing these specific density anomalies, which exoplanets are we talking about? Which ones are currently, at the top of the list in this hunt? What makes them so special?
Right now, we're looking closely at worlds like Kepler 1649c, TRAPPIST-1, and also Gliese 581P. There are others, but these are really compelling.
Kepler 1649c, TRAPPIST-1, Gliese 581P. And what's special about them?
Well, first off, they're located within the habitable zones of their stars. So the right distance, roughly, for liquid water to potentially exist, at least based on temperature.
The Goldilocks zone.
Kind of, yeah. But what's more profound, really, is that their internal structure, which the AI inferred from that density data, it strongly suggests they could host these global oceans, but safely shielded under icy crusts.
So not surface oceans necessarily.
Probably not. Which actually reshapes how we even think about the habitable zone. It's not just about surface temperature anymore.
Right.
It's about the potential for these shielded, stable ecosystems hidden beneath the ice that vastly expands the potential cosmic real estate for life.
Okay, this is where it gets really exciting.
Hmm.
What do these hidden oceans, these subsurface oceans, fundamentally mean for that huge question, the possibility of alien life? What's the direct connection?
It's a very direct connection, actually. It boils down to this. Oceans mean chemistry,
Okay.
and chemistry means the potential for biology.
Right.
If these waters are anything like Earth's deep oceans, and remember, our deep oceans are teeming with life, even in really extreme spots like hydrothermal vents.
Chemosynthesis and all that.
Exactly. Then microbial life, or maybe even something more complex, could already be evolving there. And critically, these subsurface environments, they're incredibly stable.
How so?
They're shielded from surface radiation, shielded from those nasty stellar flares, especially from red dwarfs.
Oh, okay.
So they provide these consistent conditions where life could potentially flourish undisturbed for millions, maybe even billions of years. It's like a vast, protected incubator for evolution.
Wow. And that idea itself,
Mhm.
subsurface oceans,
Yeah.
it isn't entirely new, is it? We have examples closer to home that make this feel a bit less out there.
Exactly right. We've already found really strong evidence, compelling evidence, of vast subsurface oceans right here in our own solar system.
Europa.
Europa, Jupiter's moon, is the classic example. And Enceladus, one of Saturn's moons, too. Both are considered prime candidates for hosting life precisely because of those hidden liquid water environments.
Right, with the plumes and everything on Enceladus.
Exactly, the geysers venting water into space. So what we might be seeing light years away, thanks to AI's, incredible sight,
Yeah.
it could be exactly the same kind of setup that makes Europa and Enceladus so incredibly compelling to astrobiologists right now. It gives us a real, tangible framework to understand these new exoplanet discoveries.
This is all incredibly exciting, a real testament to AI's power. But, okay, let's ground ourselves for a second. Reality check.
Okay.
Despite these amazing discoveries, what are the immediate hurdles, the limitations to actually confirming life, or even just exploring these worlds right now? And, what's next on the horizon?
Yeah, you're right. There are significant hurdles, huge ones. While AI can point the way with amazing precision, we obviously can't drill into these exoplanets yet.
Damn soon.
Definitely not. And space travel to these worlds, it's simply impossible for now. We're talking light years. That's fundamentally different from traveling within our solar system. However, this isn't the end of the story. Not at all. We have future telescopes planned, next-generation observatories like LVOR,
OVWAR.
the Large Ultraviolet Optical Infrared Surveyor, and HABEX, the Habitable Exoplanet Observatory.
Okay.
These are being designed specifically with capabilities that might give us direct images of their atmospheres.
Analyzing atmospheres from light years away.
That's the goal. And if we can analyze their atmospheres, we might find biosignatures, chemical fingerprints of life, or at the very least, get more definitive clues about those hidden oceans and maybe what might be stirring within them.
So despite the huge distances and current limitations, it really sounds like AI isn't just another tool in the toolbox here. It feels like it's genuinely reshaping how we even think about finding life beyond Earth, extending our senses almost.
Precisely. I think that's a great way to put it. AI isn't just a tool. It's truly extending our senses out into the universe. It's revealing environments we literally never thought possible or perhaps probable for life before. It feels like a fundamental paradigm shift in how we approach astrobiology. It lets us ask questions and maybe find answers we couldn't even properly formulate a decade ago.
So as AI gets smarter, our reach just gets wider.
Right.
One day, maybe we won't just detect these oceans. Maybe we could actually hear the hum of alien life beneath them. What do you even imagine that hum would sound like?